The rate at which water drains from a tank is recorded at half-minute intervals. Use the average of the left and right endpoint approximations to estimate the total amount of water drained during the first 3 minutes. So let's say if you have like 10 liters per minute of water coming out of the drain, and you did that for say 5 minutes, then this area gives you 5 times 10 gives you 50 liters. That's the amount of water drained from the pipe, drained from the tank. So once you think about this simple example, you realize that this problem at hand is really about finding the area under some curve. Now we don't know the exact shape of the curve, we just know the values at these points. So if I say this is time and that's liters per minute, then let's say here's 56. At 0 it's 56, and then gradually it goes to 54, 52, 50, 48, 46, 44. Yeah. And it could be just a straight line, or it could be like something like that. Okay, we don't know because we only know the exact values at the half-minute intervals. But let's say this is the area that we want. Okay, so how do we approximate the area under the curve? Well, there are many methods, and in here they want you to use the average of the left and right endpoint approximation, which we call the trapezoidal method. Okay, so this is essentially a trapezoidal approximation. Okay, so how do you approximate using the left endpoint? Well, first you have 0 to 0.5 is one interval, 0.5 to 1 is another interval. So you count the intervals, then you have 1, 2, 3, 4, 5, 6 intervals. So there will be like 6 intervals. And for each interval, the left endpoint rule is to multiply the base length, which is 0.5, because it's the length from 0 to 0.5 is 0.5, right? Base length times the height. But which height do you use? Do you use the left one or the right one? And the left endpoint rule says you use the left side. So this is your height. So you do base times height, and you end up with this rectangle as the approximation of this portion. So you keep making these rectangles whose left endpoint is on the curve. So overall, the summation of these things will be slightly overestimating the actual area. Okay. All right. So let's think about this. You see that the base length is always 0.5. So the left sum would be 0.5 times. Then for each interval, you want to choose the left endpoint. So from 0 to 0.5, the height is 56. So you choose that. That's the left side. From 0.5 to 1. 54 is the left endpoint and 52 is the right endpoint's height, right? So 54 being the left endpoint's height, so at 0.5 the height is 54, so that's the left endpoint's height. You add that, so you keep adding these numbers, and the only thing you have to watch out for is eventually when you're at the last interval from here to there, the left endpoint is 46, right? That's what you put. Okay, and using a calculator, or you can just sit down and add. The numbers are not that hard to add. Like for example, this is 110, right? 52 plus 48 is 100. So adding 50, this gives you 150. 110 plus 150 is 260 plus 46. That's going to be 306, and dividing by 2. Multiplying by 0.5 is dividing by 2, so that would end up being 153. Okay, now let's do R sum, right sum, which is for each interval you use the right endpoint's height. So the base length is still 0.5 as before, but the right endpoint's numbers are 54, 52, 50, 48 plus 46. This time we end at 44 because if you look at the last interval, the right endpoint has the value 44. Okay, right. And if you do that, you're going to see that it's going to be 147, and then finally the average, which we call the trapezoidal rule, is the sum of the two things divided by 2, which gives you 150 liters, and that's it. That's the answer.